So welcome, Susanne.
Thank you.
Yep, and Susanne is the COO and another co-founder, so this time of 1928 Diagnostics. And it's a very, very exciting company, I think, focused on infection diagnostics.
Yes.
And maybe I can just ask the audience just quickly. So anyone care to hazard a guess the background of the name of 1928 Diagnostics? Anybody know? Okay, do you get to answer?
Not Kristen, she's the CEO of the company. I think you shouldn't ask her.
Okay, you're disqualified from this competition. So, anybody else? 1928 Diagnostics. Sorry? Very good. Excellent. Yes, it was the year when he discovered penicillin. Is that right?
That's right.
But you know what? There's one other interesting fact, I think. So he actually, does anybody know the date when he discovered it?
The date?
You got your wait, anybody else? No, not Christine. The date when Alexander Fleming discovered penicillin, that Petri dish that he left with the mold on it. Was it St Mary's College in the UK, in London?
Yeah.
A Scottish guy.
Yep.
But the date. Sorry? September it was, and it was actually tomorrow. So the September the 28th, 90 years ago. So he came back and he found that Petri dish with some strange mold all over it.
Yeah, that's right.
Maybe some of these guys are thinking what discoveries they're going to come back to. Serendipitous accidents that they're going to come back to in their labs tomorrow. So anyway, yeah, it's very, very cool to learn that you guys were actually named earlier this year of one of the, I have to read this, the world's technology pioneers by the World Economic Forum. So congratulations.
As a matter of fact, Christina just came back from Tianjin for the first World Economic Forum conference. So she was very inspired after that.
Where was she? Sorry?
In Tianjin,
okay.
In China.
Okay.
It was a big conference for World Economic Forum.
Past recipients are like companies like Google and Airbnb and Spotify as well.
Yeah.
I know.
We got nice company there.
Very good. Okay, cool. And just one other thing. I actually saw, I don't know if you saw it as well, but did you see that really cool article in Göteborgs-Posten last Sunday? Featuring the one and only Lotte Gummarsson and Jennifer Granqvist. And did you see that? Do you not see it?
She looks surprised.
in Göteborgs-Posten. Yes, yeah. You know, I'm in the media all the time, so exactly. So, but there was a really, really cool article in Göteborgs-Posten. If you haven't read it, you should go and try and find last Sunday's Göteborgs-Posten. There was a big article on Sahlgrenska Science Park, and Lotte, she actually talked about the importance of going global from day one. And I think that's what you're going to talk about today.
Yes.
Cool.
Thank you so much for inviting me. I'm going to tell you about 1928 Diagnostics, what we do, and I'm also going to touch upon how we have started the company and really thought global from day one. Yeah, so this is a title, Controlling Antibiotic Resistance. I'm going to tell you how we do that. So we are producing a clinical decision support software for infectious disease. We do have a cloud platform that can enable the hospitals to have precision use of antibiotics and also do powerful infection control. So antibiotic resistance or antimicrobial resistance, or AMR, is a problem that I think almost everyone in the room is aware of by now. It's a huge problem. If you look at the blue fields, you can see that several 100,000 people die every year today from resistance. If you look ahead of time, in 2050, you can see that 10 million people is thought to be dying from resistance in that year, every year. And that is more than the people dying of cancer today. So it's a growing problem that will have enormous effect on how we do healthcare, and minor infections will again kill us. And this whole thing will cost us $100 trillion up till then. So that is a fantasy sum. So how do we tackle this problem? Well, we're digitalizing infection diagnostics, first of all. Even since Alexander Fleming discovered penicillin, diagnostics has been done in the same way. You culture antibiotics together with different, you culture bacteria together with different types of antibiotics and see if it grows or not. We want to push this into the digital space, look into the bacterial DNA and look for the resistance genes and mutations in there, because that has the answer to if the bacteria is resistant or not to which antibiotic. So we do a bacterial DNA analysis tool for the clinic, and that can be used both for diagnostics, as I told you before, and for infection control. So this is how it works in the clinical routine setting. You have a patient with an infection. You can take out the blood or the urine or any other tissue and remove the bacteria from that sample. From the bacteria, you take the DNA, and you can read the DNA in modern DNA sequencing equipment that are available today at most university hospitals and larger clinics. Unfortunately, they are not used so much in clinical routine. They're mostly used for research, and that is because you get out a data file with data that is unprocessed, and you need a lot of tools and knowledge to be able to handle this data file. So that's why we started the company. In our service in the cloud, we take that whole data file and process it and matches it to our own resistance databases and get the doctor a result back that can be used for clinical decision support. So you upload the data from the machine, the data analysis occurs in only a couple of minutes, and then the result comes back to the doctor. So the result is a resistance profile telling the doctor which antibiotics that can be used to treat this infection. You can detect if the bacteria has different toxins that will affect the patient and make them even more sick. And you can also do outbreak tracing in a very, very efficient way. So that is that if you compare with today, when you can find out where you have a patient with an infection, when did the infection occur, and who is the patient. It's really difficult with today's method in real time to get any type of association between different patients and know the transmission routes and so on. All these investigations are done retrospectively today, usually. So with our method, you can take the bacterial fingerprint from the bacteria from different patients and compare them and see if they're very similar or not. If they're very similar, that will tell you that you have an outbreak coming up. So we have association between cases. You find out the outbreak origin, and you can stop the transmission routes. You can also find out the bacterial properties, of course, resistance and all of that in the same analysis. And last but not least, we're building data sharing system. So you can share this data about the bacteria between different hospitals in different countries. Hospitals and authorities can share the data and so on. So you can see how the different bacterial clones affects patients in time, so to say, in real time. And that is a really powerful way of doing outbreak tracing and infection control. We have as a primary business model a subscription model. We are a software as a service company. You can also pay per analysis if you want to do individual samples. And now I come to the point of global from day one. So already from the start, we started in Gothenburg. It's a great place to start a company. It's a lot of knowledge here, a lot of good people. You can develop stuff very good with finding employees and so on. And Sweden is extremely good at fighting antibiotic resistance. But we are addressing a global problem. Every country in the world has antibiotic resistance. The bacteria do cross borders, so even in Sweden we get the bacteria from elsewhere. We work with data sharing, so that means that if the tool is going to be have a lot of power, we need to have a lot of data. So we need to be all across the globe. We have a cloud-based product, so as soon as we launch the product, it will be technically available everywhere. And we want to benefit from that. We are a startup company in Sweden, and we have raised a lot of capital here. But to be really competitive on the global market, we need to have access with the capital markets that are the strongest. So we need capital from US or even some parts of China or other Asian countries are also to think about. We are working on an immature market in many ways. These machines are rolling out now in clinical routine, but we're not there yet. So we need to work with the best of the best, the early adopters, no matter which country they are in. And that also gives us a lot of access to different experts in different parts of the world. We have a first mover advantage, so we are the first company in the world doing this. To keep ahead of the competition, we need to move, and we need to move fast. We can't stay here in Sweden and move around in our own country only. Finally, we started the company to fight a problem. We want to make an impact as soon as possible, and we do that the best by trying to look at the whole world as our place to work in. So thank you so much for listening, and I'll be happy to take any questions you might have. Jamie?